In this video, I'm going to find the divergence of the vector field f, which is equals to x cubed plus y cubed I plus 2xy squared j plus 2zy squared k. So given that vector field, to find its divergence, we know that if we are given a vector field f, the divergence of f by definition is the dot product of grad and f. Our grad is the partial derivative with respect to xi plus the partial derivative with respect to yj plus the partial derivative with respect to zk. So for our divergence there, we'll write the grad, take the dot product with this given vector field, so dot that f. So I'll now go on and evaluate that dot product. And we know that when you are evaluating the dot product, we'll be multiplying the corresponding elements. And in this case, when you are looking at the I, we would have the partial derivative with respect to x of x cubed plus y cubed. So I'll go on and write it, the partial derivative with respect to x of x cubed plus y cubed. Then I go on to the next part, where we are looking at the j. So we have the partial derivative with respect to y of 2x y squared. So I'll write it down, the partial derivative with respect to y of 2x y squared. Then go on and look at the part where we have the k. We are having partial derivative with respect to z of 2z y squared. So I can then go on and write it down there, the partial derivative with respect to z of 2z y squared. And the next step now is to evaluate those partial derivatives. So I'll start by this one here, the partial derivative with respect to x. For the partial derivative with respect to x, we will be differentiating with respect to x, but treating y as if it's a constant. So when you differentiate that, we get 3x squared. Then I'll move on to the next partial derivative, this one here, with respect to y. We are differentiating with respect to y, but treating x as if it's a constant. So what we have there is 4xy. Then go on to the next derivative there, this one here, the partial derivative with respect to z. We are differentiating with respect to z, but treating y as if it's a constant. So our result there will be 2y squared. So what we are having there is the divergence of this vector field here is 3x squared plus 4xy plus 2y squared. And what we should recall is that when we are taking the dot product of two vectors, the result that we get is a scalar. Using that information, we will know that the divergence of a vector field is a scalar.